Hey you guys, so welcome to part 3 of this NeuroEvolution of Augmenting Topologies speciation part. Alright, let's get started. So, I'm going to open up our project, and hopefully this is going to be the last part. So, right now we're going to create the speciation class, the species class, and then implement speciation in our genetic manager script. And then hopefully by the end of this we'll have the different colors to represent our species. Alright. So, this is the familiar scene. Let's go to projects and let's open up our neat genetic manager script. Now I'm going to open up the file real quick. Alright, so now our project directory is opened up in Visual Code. Let's go back to Unity and create a new script. Let me full screen this. C# script, and we're going to call this one neat species. Now that we have this open up, we can begin writing it, and we don't actually need any of these classes. And we don't need mono behavior at all, because we're not going to use any of those Unity classes. Alright, so for the species class, we're going to have a couple of variables. One thing we're going to have is a mascot. So we're going to have private neat genome. I'm going to call it mascot. This mascot is going to be one creature within this species that represents the species as a whole. So basically, whenever we have a new creature get created, we're going to compare that creature's genome to the mascot of a species and see if the compatibility distance is within a threshold. And if it is, then it is the same species, and if it's above the threshold, then it's a different species. And so we're going to have a list of these species in our genetic manager, and we're going to compare all new creatures to this list of species, so to a list of these mascots for each species. And if a new creature doesn't match to any of them, then it gets put as its own new species, and it is the mascot. So we have one mascot to represent the whole species, and we take its genome. And then we need a list of all of the genomes of the creatures that are in this species. This will be a neat genome list, and we'll call it members. Okay, and now for the coloring of this species, we are going to need to store it. So we're going to store a color value and call it species color. And then finally, we're going to have a species fitness value. So this is the fitness for the whole species. So let's create the constructor next. Not my shift seems to be working weird. Alright, so in our constructor, we'll pass in the first genome. So when we create a species, we'll pass in the first member. Species. And our first member will be the mascot to start off with. Now we need to initiate the list. And we need to add our mascot or our first creature to the list. Okay, now to start off with, we're going to give our species a random color. So species the color equals new color value, and is going to be random dot range. We're gonna go 0f to 255f. I think 0 to 255 should work. Let's try that first and see if it gives us errors, and then if it does, we'll do something else. 0 to 255 as well, and then range 0 to 255. Okay, so what's happening here is, we're creating a new color value, and I wish my Visual Studio would do the pop-up of the extra window, but whatever. So it's RGB, right? So we're giving it a random value from 0 to 25 for the R, a random value from 0 to 25 for the G, and a random value from 0 to 25 for the B. So yeah, we should be able to create any color out of these, like we have every color possibility here, and so because we have so many possibilities, the chances of a species having the same color will be pretty low, which is good, which is what we need. Alright, and then finally species fitness will equal 0. Alright, that's our species class basically. We will add some functions, but for right now we're pretty much good. I think the only function we will need to add is getting a random member, but honestly we don't even need to add that function here. Okay, let's get moving on to the genetic manager. Now, in the genetic manager, we have our sorting population, muted population. We're just going to create another function called speciate population. And for the speciate population, first of all, we're going to need to add a couple of variables, and we'll add those right after the starting population. Let me create a little comment here by doing control/. Alright. And then for speciation, we're going to need to first of all create a public array. Well, we're going to create a public list of all the species that have existed in our simulation. And then we're going to create a dictionary, a public dictionary. And our key is going to be the need genome, and our value is going to be the species. All right. Now we create the function. I'm going to get rid of these comments because we'll rewrite it if we need it. And actually, we have to delete these two lines as well, as we're no longer going to be calling it in our sort population. Let me add some, clean up this code a little bit. I'm trying to find a good place to put this function. I guess one of the ways to do this, since we're actually going to be calling speciate population in our repopulate function, we're probably going to call it right after mutation. This is where we're going to call it. So we'll put it right under the mutate population right here. I'll write it inside the class. So our function is going to be a private void function, and we're going to call it speciate population. Okay, now this is where all the fun begins. We're going to initialize our all species dictionary. And so this will happen since repopulate is called every generation, right? Every time we want to start the next generation, we call it repopulate. The all species dictionary is going to get rewritten every time. We also need to initialize our all species list, but we're going to do that in the start function, and we'll get to that. So right here, we're going to do neat genome, neat species, and there you go. Okay. So, like I said earlier, what we're going to do is we're going to compare all the current creatures, to the members of the mascots of the species list. So we need to loop through all the current members, right? And now that we have that, we're going to get the genome from from each of the network in our starting population. So we're going to call it genome all neat networks, since our starting population is going to let us know how many, what the count of our all neat networks is. So we can use I to loop through the all neat networks, and we can get the mascot. No. We can get the genome. What did I name it? my genome. Let's make sure that the naming is right. Work my genome. Perfect. Alright, so we got the this way we're gonna be able to get like we're able to loop through each network and get its genome. And for each network, first of all, we'll create a bool right here called found equals false. So if we do see that the it's within the compatibility threshold, then we'll put found equals true. And if it's not, we'll create a new we'll add it to the species. We'll create a new species for it because it isn't compatible with any current species. So now we loop through for each meat species, and we'll name spec in all species. So this is where we're going to get the mascot and do the comparison. So we don't even have to comp this equals. We don't even have to actually store the mascot in a variable. We can just call the function right here. Neat utilities dot, what did I call it? Get compatibility distance, and we pass in. Let me see. I forgot. First genome, second genome. The second genome is the one. Okay, so first genome, second genome, and then all the rest. Okay, the constants that we have. So this will be genome for the first one. Second one is species dot mascot. So this gets the genome of the current mascot. And then C1, C2, C3 for our constants. That will get us the compatibility distance. And then we check if comp this is under. Now we need to create a variable for our compatibility threshold, whatever we set it to be, but we'll call it compatibility thresh. That's too long. We'll call it comp thresh. And now if it is less than the comp thresh, that means that it is part of the same species. So we have to add the member. So it's dot members dot add, and we're going to add in the genome. Next, we're going to index it in our, and remember, we still have to initiate our all species dictionary for this check. But anyways, next we have to do all species dictionary. This has been initialized. All species dictionary dot add. We're gonna add the gene to the species map to. And then on networks, set. We're gonna have to add a new function to our all neat networks to set the color or we can probably just do it here. I believe we can all do all neat networks dot. I just need to know what the okay. Next, we're going to do found equals true, and then we're going to break out of this loop right here. Now, we need to go to our neat network and we need to add a color thing, but I don't think I actually want to do it that way anymore. And I guess it kind of depends on how. I don't see why we would need to store the color in the network. Yeah, I just don't think we need to store the color in the network. Because I want the neat network neat network to be kind of separate from this, at least in the variables and everything. I want it to work on its own if I want to pull it to another scene or something. Okay, but that's fine. All right. Now that we broke out of this, and I think actually we will have to do something. We'll have to do something with the color, but once we finish the we'll actually probably set the color in the body, in the actual fish controller script right here. And that way, when we start each individual body, we can just get the colors from there. All right. So let me look at where we do the spawn body real quick. This is where we create a new prefab. All right. Yeah, we can probably just put the color in the fish body. But we don't have the reason why it wouldn't work is because we don't have a body at this point. Our bodies get spawned after kind of everything is done. So let's go up to our repopulate. Our spawn bodies are coming in right here. If we speciate up here, we have no body to do it in. We need to store the color somewhere. We have this stored in the individual species. Okay, I got it. We have our all species dictionary right here, right? And each genome matches to that species. I believe we can use that to get the color of each genome. And then right here, when we're going through each neat fish, we can set the color in the controller. That's actually pretty cool. All right, let's do that. Let's see if that works. We're gonna go back. We're gonna actually close out of our neat network. Let's go back up to where we're writing our speciate population function, and right here, first of all, let's add that semicolon right here. Not right here, it's already all done. Now, so this is already all done. So now we're done with this loop altogether. So once we break out of here, this will happen again. Once we break out of here, this loop will run again for the next population. But now after we break out of this, we want to check if not found, right? So if found is true, we break out and this doesn't hit. But if found doesn't become true, this does hit. And so that means we have to create a new species. If found does not equal true, that means that nothing was compatible. The new creature we create is not compatible with any species that exists, and we have to create a new species. So we're going to create neat species equals new neat species, and we're just going to pass in the genome. Alright, and now we need to add this new species to the all species list. Which is still not initiated. We'll do it in the start or awake function. Species, and now we have to add it the species and genome mapping to our dictionary. Species, which is going to be lowercase, and then actually we're done right there. Perfect. Now finally we're going to need one loop at the end of this for cleanup. Now this loop is basically used to remove any species that do not have any active members. For int I equal all, so this way our all species list won't ever become overpopulated. Like if this simulation runs forever, then that all species dictionary will just keep storing all the species that have ever existed over and over and over. If we go to like 1 billion generations, the amount of memory we're using is going to be crazy. So this is just to keep everything clean. And we're doing a reverse loop. So we're looping through this backwards. The reason why this loop looks a little weird is because we're actually starting at the end of our list. So we're starting I equals, so if our list is 20, I will equal 20. And then we're going to stop the list once it hits 0 or is less than 0. Or we're going to keep the list running while I is greater than or equal to 0. So it'll go from 20 to 0. And then we're going to subtract 1, 1. So we'll go 20, 19, you know, down instead of the normal up. Now we're going to do if all species I dot members dot count equals 0. So if it's an empty list, if there's no members in there, I believe this is going to be, we also need to do, to make this perfectly clean, we would have to do another thing. But for right now, we don't. We're going to do all species remove at, I'm going to do I, so we're going to remove that value if it doesn't exist and else. And this is actually the more important reason why we're doing this loop, and is to randomize our mascot. We don't want our mascot to always be the first one that exists. We want our mascot to kind of, we want it to just represent the, an ideal case, it would be, we would use a function to check all the compatibility thresholds and find an average, right? And find the mascot that is closest to that average. But in this case, we'll just randomize it and pick one out of it. And it's just good so that our mascot isn't always the first creature that got put into the species. In fact, the mascot should be the creature that is the most fit within the species, but this is a kind of cheap fix and it'll work. All species I dot members, no, dot mascot equals all species I dot members, and we want a random member, which is, so we'll take a random dot range from 0 to all species I dot members dot count. I believe is count -1. Oh no, it's just count. Okay. And that should be that. So this loop right here will remove if any species list is empty, any species members are empty, then it will remove it. Otherwise, it will randomize the mascot. And the most important part of this isn't the removing, because it actually probably won't ever remove something, because it will always have a member in the list until we start deleting members from, like, the initial mascot we create is part of that, part of the members list. So it will be above 1 when we initialize it. So we'll have to remove, once a creature dies, we have to remove it from the species members list. That's when this function will start actually, like, this if statement will actually start taking effect. But the most important part about this is this if statement for the speciation. Okay. Now that that's done, we can move on to getting the color set up. Our speciation should be working now for the most part. We need to call the function, which we'll call in our repopulate right here. We'll call it speciate population. Okay. But right now, the colors won't work, so we won't really be able to see it. Also, we need to start initializing the stuff for this function. The things we didn't create yet are, we need to create a, where'd it go? Public compatibility threshold. And we're really just going to set that. So we'll go up to our, where do we do the speciation stuff? Right here, and we'll put in public float comp thresh equals 1f. Actually, for right now, I want to keep it at 0.5, and then we can change it. Here we go. All right. So we have our compatibility threshold, but we still have to initialize our species list, right? So we have it right here, but we don't have it initialized, so we'll initialize it right here. New list of species. Cool. So I think everything is initialized how we need it, and the function is being called. Let's go ahead and go to Unity and fix all the errors that will be there. Okay. Oh. All these have to be public. That's my bad. So go to your neat species, the class we made, and change these to public, 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 public. Perfect. We'll leave this remove at, where did it go? Right here. Ooh, this has to be a capital R. Perfect. Cool. Now when we press play, want to make sure there's no errors. Yeah, looks good. But clearly we don't really see anything. We can't really tell if this is working or not. So let's go ahead and check that out. The way we're going to see if this is working or not is by setting up the coloring for this. So let's start setting up the colors. Now, one thing, let's go to our unit. Let's go to Unity. Let's go to projects. Let's go to our prefabs and click the fish. And let's scroll down to the trail renderer. We need to manipulate this right here, this color value of this flag. Let's see. First of all, let's go to our fish controller. Go up, and we're going to create a new variable here. And we're going to call it color. My color. Okay, so it's going to be a public color value. We're going to set this color value. I'm probably going to set it right in here. Right. So we have a public color right here, but how do we get it? That is the question, right? We're going to set it exactly where we set the the fish controller's network in the genetic manager. So let's go down to spawn body, right? And this is where we assign all the stuff for the neat fish. And so over here, we're going to assign color as well. Neat fish I dot game object dot get component fish controller dot my color equals. So now we go through our what do we call that? We want to go through the dictionary of the species. So all species dictionary, and we want to get the index from our genome. Neat networks I dot genome dot my genome. Right, so this will give us the species that it is currently on. Well, it should. And once we get the species that should be attached to that fish body, we can get this color right here, species color, which gets initialized. So it should be there. It will be dot species color. Yeah. Let me go to my fish controller. So this is a public color. We should be able to see different colors. Problem. Let me see something. Make sure I'm accessing the right item. Yeah. He and oh. The heck? Yeah. Isn't that what I'm doing? Okay, so I'm gonna comment this real quick. I'm gonna do a print all species dictionary on networks my genome. We know this is set right here. There's something wrong. We don't ever initially speciate. No, yeah, we speciate right before this. There's our species dictionary coming up empty. I doubt we can even get the count of a dictionary like. Now what? I have it commented out. Oh, wait. On body. Yeah, right here. That's what's happening. Okay, so if we go to the start function, right when we start, we also want to do the speciation. Right here, we'll do speciate population. Perfect. No, honesty, I don't even know why this is. Repopulate should be called right here. Anyways, but we'll deal with that when we do the cleanup, if we do get to the cleanup of this code. And now that spawn body, species population is being called before spawn body up there, we can go down here and turn this back on and get out of that. Okay. Perfect. We don't see colors yet. Obviously, we haven't set the color. But I just want to see, we should be able to see that these two, well, they might be part of the same species. So let some changes come in here. All right, now we pause this and we look at each of the fish. Go down to their controller. White. Oh yeah, because we didn't set it in the controller. All right, let's go back to our neat genetic manager. Well, let's go open up our folder. Now let's move to our fish controller. Now here, where would we add this? Probably in the start. Yeah, probably right here. Yeah. Okay. We'll do it right here, and we'll do. Oh yeah, the color should be being set. Let's try this. Equals new color for some random values. Deposit down to our fish controller. This color is some like red value right here. For some reason it's not showing in here, but if we click it, it is a red value. Okay, if we go to this one, we click it, it's a blue value. So you see those two were different species, so they got different color values. Now if we go to the fish controller, and right here in the start, we can do game object dot get component. Now we're going to get our renderer. Dot material dot color equals my color. Right, and we no longer need it to be this. We'll leave it. That was just to debug. So leave my color like this, and then do this. Because my color is being set already. Get component. Dot. Now we also, let's go to over here real quick. Looks like that. Projects, go to our prefab. Okay. So we want to do that flag thing. So we want to get component. We want to get the trail renderer. We want to get the start color. We want to equal it to my color. Alright, we save that. And let's see if that will do it for us. What? Why? They are all starting off white, and they'll probably continue to be white. It's because when I'm setting the color, the secondary color is being set. But what I mean by that is when we go to one of these fish and we click the color, you know, this secondary color is being set. they keep their colors usually in. Let's go back to our genetic manager where we're setting the color, which is right here. Species color. Actually, let's go to our genetic manager here. Need fish. I need to be able to see that species, or at least what's in it. Well, first of all, I'm going to try something simple real quick. Let's go to our neat species. And so let's first change all of this to F. And now I want to divide all of this by the largest value, which would be 255F. The reason why is now we'll get a percentage instead of a, like they had in that thing we saw. Save that. Let's run this one more time. Yeah, that did it. All right. So we need to have this in percent form for some reason to get that first color. Okay. So go to your neat species and change this to this exact line of code. And now the thing we've all been waiting for, finally. Press play. And we have speciation. So you see each species has its own color. But right now it kind of looks like everything has its own color, no? So we'll do something else. We'll go to genetic manager and change first of all these values right here to 1 and 1, right? But we also want to, where'd it go? We want to change our compatibility threshold to something higher. So we'll change it to 1. We'll change it 1.5. You see, now we see that all of them are part of the same species because our compatibility threshold is so high. If we move this up to, let's say, 30, over time, we should see a difference. Unless, of course, our compatibility threshold is way, way too high. Okay, let's change that down to 1.2. Yeah, let's do 1.3 actually. Yeah, see, so we have one of a different network completely than all the rest. Change that to 30. There's a new species, but it keeps dying out. There we go, new species. And it actually is doing better than the old one. But not good enough to be saved. Alright, you guys, well, speciation it does seem to be done. it's pretty cool stuff. I'm actually gonna pause this, go to game, maximize on play, and then press play. Move this up to 30. And I'll just let this run for a little bit so you guys can see how the speciation is working. But yeah, for the most part, this is the end of speciation. There could be some code cleanup, but yeah, overall, this has been fun. If you guys have enjoyed this, please leave a comment. Let me know. If you guys want to see more of this, we still need to do the visualization of the network, and the visualization of the network is next, and then the crossover of these creatures. And then we'll do some better fitness for the we'll do fitness speciation wise. So right now, all our fitness is still based on individuals, but for need to be really effective, it has to be species based. So yeah, there's still more to do, but again, I want to base it off of public interest. So if you guys are interested in it, I'll be happy to do more. Leave a comment, let me know. Thank you guys for watching. I hope this was interesting. Have a good day.